Here we're asked to expand the square root of 1 plus 2x for the absolute value of x is less than a half up to the term in x cubed. So this is a binomial expansion with a rational power because we have 1 plus 2x to the power of a half. The square root can be written as a power of a half. We need to work out what this is. To do this, we're going to use the formula we saw in the previous notes, which I have copied here so we can refer to it. It's important to note that this is only true in these instances where the absolute value of x is less than a half, and we'll come back to that at the end of the question as to why that's true. But let's start substituting into the formula. 1 plus n, where n is going to be a half in this case, and x, but x is not x. X is 2x in this case, so it's a half times 2x, plus n is a half, n minus 1 is minus a half, over 2 factorial, and x squared, but it's not x, it's 2x, so it's 2x squared, plus n is a half, n minus 1 is minus a half, n minus 2 is minus 3 over 2, over 3 factorial, and then x cubed, but it's not x, it is 2x cubed, and this carries on forever. But we are only asked to go up to x cubed, so I'm going to stop there. Now simplifying this, we get 1. A half times 2x is just x. We have a half times minus a half, so it's going to become negative, which is a quarter. A quarter divided by 2 is an eighth. We've got then 1/8 times 4x squared. We've got plus, and this time we've got a half, times minus a half is minus a quarter, times minus 3 over 2, so this is going to be plus 3/8 over 6, because 3 factorial is 6, so that's going to be plus 3/8 over 6, so that's plus 3 over 8 times 6 is going to give us 48. And then 2x cubed is going to become 8x cubed. That's 1 plus x minus, the 4 is going to cancel with the 8 to give me a half x squared. And this is going to give me, well, 3 times the 8 is 24. 24 over 48 simplifies down to a half x cubed. So up to the x cubed term, 1 plus 2x to the half, or the square root of 1 plus 2x, is equal to this polynomial. Now I said we'd come back to this. This is only true if the absolute value of x is less than a half. The reason for that was because, remember, we started by doing this by looking at the series expansion of 1 minus x to the minus 1 as 1 plus x squared plus x cubed, and this was really the sum to infinity of this infinite series. And because this was a sum to infinity of an infinite series, x, or the r value, the common ratio, had to be between minus 1 and 1. So in this case, x has to be between minus 1 and 1, but it's 2x here, so 2x has to be between minus 1 and 1, no, not equal to, strictly less than. And that is the same as saying that the absolute value of x is less than a half. So that's why this bit here is included, because that is the values that this actually works for. Any x value outside of this range, this would not be equal.